Hello friends, today's question. For a simple pendulum, a graph is plotted between its kinetic energy and potential energy against its displacement d. Which one of the following represents these correctly, and graphs are not according to scale? So first of all, let's try to understand that in case of the simple pendulum, there is change of potential energy into kinetic energy and from kinetic energy to potential energy, okay, as it changes, goes from one position to another position. So we can say that for simple pendulum, kinetic energy and potential energy changes as pendulum swings back and forth. So let us try to understand the key points which are involved in the potential energy as well as the kinetic energy. Key points. The first key point is displacement. In this case, the displacement is given as d. Usually, we take this displacement in the form of x. So first is displacement d. So this displacement is nothing but the horizontal distance of the pendulum from its mean position, and mean position is the lowest position in the swing, lowest position point rather in the swing. So we can say displacement d, this is the horizontal distance of the pendulum bob from mean position. And here mean position means the lowest point on the swing. Lowest point on the swing. Second is our kinetic energy. So the kinetic energy of the pendulum is maximum at the mean position, or we can say that speed of the pendulum is maximum at the mean position. So the kinetic energy is maximum at the mean position and decreases as it moves towards the extreme position. Okay, extreme position can be to the right as well as it can be towards the left. So we can say the pendulum, here pendulum means nothing but a bob. Okay, the pendulum has its maximum speed at mean position. So mean position, we can also say that the kinetic energy is highest at when D is equal to 0. You can say kinetic energy is highest at D is equal to 0. It means at mean position the kinetic energy is the highest. And you can also say kinetic energy is highest at D is equal to 0 and decreases as the pendulum moves toward the extreme positions. The extreme positions. Next is our potential energy. Potential energy. So potential energy is maximum at the extreme position where D is maximum and 0 at the mean position. Potential energy is maximum at the extreme position where D is maximum and 0 at the mean position. And last is our total energy. Total energy, which is a combination of potential energy and kinetic energy, which is combination of kinetic energy and potential energy, and it remains constant for entire swing of pendulum. So these are the four things which are key things which are associated with the pendulum. Therefore we can say that, let us suppose this is the pendulum and this is the bob. So it is going to swing between two extreme positions, one towards the left and another towards the right. So these two are its extreme positions, and this is our mean position. And at this position D is equal to 0, and these two are the extreme positions. Where D will be maximum here as well as, and here also D is maximum, and here velocity is maximum at the mean position, and here velocity is 0, and here also velocity is 0. So therefore we can say that at the mean position kinetic energy will be maximum, potential energy will be equal to 0, whereas in the extreme position kinetic energy will be 0, potential energy will be maximum, and this goes for other side also. Kinetic energy is 0 and potential energy is maximum. Okay, this. So let us say that the graph of kinetic energy and potential energy and potential energy. And one key thing is that both the graphical shape of kinetic energy as well as potential energy is parabolic in nature. Okay, so we can say that kinetic energy and potential energy have parabolic shaped graph. Parabolic shaped graph. So obviously it will be parabolic shaped graph. Okay, and let us discuss one by one, first for kinetic energy and then for the potential energy. So we start with kinetic energy, and we said that the shape is parabolic. Okay, so we can say a parabola that is maximum at d is equal to 0, which is the mean position, and decreases symmetrically to 0 at extreme position. Where d is equal to plus minus d max. So we can say this will be our left side, we take it as a minus max, and right side we take as a positive max. Next is our potential energy. So once again, the graph is a parabola. So we can say a parabola that is minimum at d is equal to 0, which is the mean position, and increases symmetrically to the max position, to extreme position at d is equal to plus minus d max. So we can plot the graph. So this is our mean position when d is equal to 0, and let us suppose this is a minus d max and this is our plus d max. So we know the parabola potential energy is minimum at d. It means the potential energy is going to start from this point and it is going to increase symmetrically to both ends. Okay, so symmetrically means it will be increasing like this, and from here also it is going to increase like this to the maximum dx value, and at d is equal to 0 the kinetic energy is maximum. So this is a maximum kinetic energy and it is going to decrease symmetrically for d is equal to max. So this will be coming like this, and to the other side it will be also going like this. So this is our kinetic energy, and this is our potential energy. And in case we can also draw the total energy, which will be represented as this way. It is a constant from one maximum position to maximum position. So this is our total energy. Okay. So from here we can write about total energy. Total energy is sum of potential energy and kinetic energy at any point, at any given point. And it remains constant. It remains constant from minus d max to plus d max. So from the option available to us in the plot, there is no, you can say, total energy is not given. Okay. So obviously C and D cannot be the options because they are entirely in the different way, where kinetic energy increasing positive side and potential energy is in the negative side. This also, no doubt, it is somewhat parabolic in nature, but it doesn't represent actually the discussion. So we have only option A and B which can be correct one. Okay. So this is a mean position. So this is 0, here also 0, this is our minus D max, this is our plus D max, and once again here will be minus D max, and here will be plus D max. So at mean position, potential energy should be 0. So we can see that the mean position, this is the graph of potential energy, so which is 0, and at the mean position the kinetic energy should be maximum, okay, which is the maximum value. So the option A is our correct one. So you can say option A is correct. You can say option A is correct. So this completes the question. Thank you.